Hi everyone, in this video we will learn about a new coordinate system called the spherical coordinate system, and then later on we will be looking at how to do triple integrals in this particular system. So spherical coordinate system, similar to cylindrical coordinate system, except as you can imagine here things look like spheres. So what is the basic idea here? Once again, it's a point in space, and we want to identify it using something different, right? So we already have x, y, z. That's your rectangular system, and we already built r, theta, z, which was called your cylindrical. And now we're trying to establish a new sort of coordinate system. So what we do, the first step is, again, we're still going to project this down to the xy plane, and we're still going to use this right here for the angle theta. So the theta remains the same as with the cylindrical. Now the difference here is we will introduce the distance from the origin. So the difference in cylindrical and spherical is that the distance in cylindrical, it was the r represented the distance from origin to the projection in the xy plane, whereas here the distance represents directly the distance between origin and the point. And so we don't want to call this r because that's going to create confusion. So we give it a new name called rho. And then we need a third, which is an angle, a solid angle from the z-axis, and this is called phi or phi. So in the spherical coordinate system, what we have is rho, theta, and phi. And then we have specific definitions. This is distance of the point x, y, z from the origin. Theta is the angle of projection on the xy plane. So same as cylindrical coordinates. And then phi is the angle made with the z-axis. And this is going to completely define a coordinate system. Now we have certain conditions. This has to be greater than 0, and the angle phi is always between 0 and pi. We don't need any more than that to make the whole shape. That's because theta is between 0 and 2 pi. So theta is already doing full rotations, and so we don't need a whole rotation of phi. Okay, so to understand or to see where the sphere comes from, let's look at what does this rho equals constant look like. So rho is constant, which means I'm looking at a set of points which are at a fixed distance from the origin, right? So fixed distance from the origin. Suppose this is rho. Now what are the values that, so if rho is constant, we have theta can be anything between 0 and 2 pi, and phi can be anything between 0 and pi. Now theta represents a rotation in the xy plane. So theta being everything means it goes around in a circle in xy plane. And phi being 0 to pi means it gives a rotation in this axis. And for each of these rotation, you get a bunch of xy plane based rotation. So if you look at what that comes out to be, if you you will have something like that, and there's going to be whole rotations around, and there's going to be whole rotations on this axis. It's not a very good picture, but it becomes a sphere. Okay, so similarly, you can try and sort of see what the different, keeping theta constant, it's still going to be a plane, and what happens if you keep phi a constant or phi a constant. The next thing we want to establish is relation between rectangular and spherical coordinates. Okay, so here we're gonna have to set things up a little bit carefully. So let me first draw this diagram. Here's our point P, and it has the regular XYZ. Then this distance is rho, and we take a projection of this, and this distance we know is r, and this angle is theta, and this angle is phi. Let me write this in a different color, so we have a color coding for now. Once I project this into the xy plane, this point has xy but a 0, right? So let's call this P prime. And if I take this projection here, this is 90 degrees, this is x, y, and z, then it's this height of this triangle is y, and if I make a projection from this point to the z-axis, then this height is z, and this distance over here is x. So that's going to, now we have a bunch of right triangles, so we can make some relation. So first of all, I am going to look at, suppose, this triangle right here. Right, so in this triangle right here, what we have is, we have a base that is z, right, and we have an angle that is phi, and we have a hypotenuse that is rho. So we get z equals rho cosine phi. And if I take this other triangle, which is over here, right, so this is also a right triangle because we have a projection at the bottom, and projections are 90 degrees. Here. So I take this triangle here. This is another right angle triangle. Sorry, do it in one. And what we have here for base is r. What we have here for angle is this, which is also phi, and we have a hypotenuse which is rho. So that gives me r is rho sine phi. And then for the last bit, we're going to look at, let's do a red here. Oh, that's the wrong thing. For the last bit, we will look at this triangle here. And in this triangle, we already have a nice relation between x, y, and theta. So in this triangle, We already have x as the base, y, theta, and r. So we have x equals r cosine theta and y equals r sine theta. So putting this together, we get x is r cosine theta, but what is r? R is rho sine phi cosine theta. That's r. And y is r sine theta. And again, r is rho sine phi. So this becomes rho sine phi sine theta. And z we just obtained directly is rho cosine phi. Okay, so we have x, y, z in spherical coordinate becomes rho sine phi cosine theta, rho sine phi sine theta, and rho cosine phi. Now note, if you add all of these and you square them up, you will end up with rho square, which is a sphere. So you can try this and submit it as extra credit. So this is true. Okay, so we have a system of converting from one to the other. So naturally, let's look at a couple of examples. One of them will be plot and find rectangular coordinate for a point given by 2 pi over 4 and pi over 3. So first of all, let's try to locate this. With the information given to us, it's at a distance of 2 from the origin. So this is 2. And at an angle of pi over 4 at an angle of pi over 3 from the z-axis. And if I were to look at its projection, that would be at an angle of pi over 4. So this would be pi over 4. So this is 2 pi over 4 pi over 3. But if I am to rewrite this in rectangular coordinate, I'm going to need the relation that we had up there. So x is going to be rho sine phi cosine theta, keeping in mind that phi is the last angle. So this is sine pi over 3 and cosine pi over 4, which will come out to root 3 over 2. Similarly, y is rho cosine phi cosine theta. That's wrong. It's sine phi sine theta. This is 2 sine pi over 3 and sine pi over 4, which will also be the same because cosine pi over 4 and sine pi over 4 are both 1 over root 2. And then z is rho cosine phi, which is 2 times cosine pi over 3, which is half, so this becomes 1. So this point is in the first octant, and it's given by root 3 over 2, root 3 over 2, 1. So this height is 1, and because it's at 45 degrees, it's equal x and y values. The reverse direction can require, a little bit of work. So let's look at one last example. Rewrite the point 0, 2 root 3, negative 2 in spherical system. Okay, so the first thing we will do is, since we have all 3 coordinates, we know rho squared is x squared plus y squared plus z squared. So this becomes 0 squared plus root 3 squared plus negative 2 squared, which is 0 plus 12 plus 4 is 16. So this is 4, only taking the positive because it's a distance from origin and won't be negative. So we get rho. Okay, now we can use z is rho cosine phi, because we have z, which is negative 2, and rho to solve for cosine phi. So cosine phi is negative 1/2. Phi is arc cosine negative 1/2, but not infinite values because the sphere is limited. It's not infinite like the cylinder, and the circles are the rotation is between 0 and pi. So we get 2 pi over 3. And then you can use either x or y, because you have x is rho sine phi cosine theta, and now you have x rho phi. You can solve for cosine theta. What is x here? X is 0. So sine 2 pi over 3 cosine theta, this gives you cosine theta is 0. So theta has to be pi over 2. So in spherical coordinate, you have r theta, which is pi over 2, and phi, which is 2 pi over 3. Okay, so that's the general process in which you can convert from rectangular to spherical. So that's it for this video. We will have separate material for how to do the actual triple integrals using these two coordinate systems that we've learned, spherical and cylindrical.